Welcome to Crash Concepts, where the economy, energy, and the environment are explored. Up next, fresh ideas and insights into the factors that are driving the world and shaping your future. Presenting information you can't afford to live without, here's Chris Martenson.
Welcome to another ChrisMartenson.com podcast. I am your host, of course, Chris Martenson, and today we're speaking with Jack Keller, CEO of Keller Blissner Engineering, one of our very own community members here at ChrisMartenson.com. In addition to being a regular at the site, Jack also happens to be one of the world's authorities on water management. Since it's arguably the most precious global resource, we've wanted to do a show on water for a while now, and so it's a thrill when we can leverage the insight of one of our own experts from our own community on the subject. Jack has spent his career as both an entrepreneur and professor and has provided advisory services in irrigated agricultural development and water management in more than 60 countries. Today, he and I will explore water and the outlook for its future and future availability. Jack, welcome. It's a pleasure to be speaking with you today.
It's a pleasure to speak to you.
Well, great. Listen, water is our most precious resource, as I mentioned, and some people worry that it's maybe the most poorly managed. What kind of future are we looking at with water supplies here in the U.S.?
Well, the water supplies in the U.S., in the west of the U.S., and I think you have to say the west is really west of the Mississippi, not just far west. It's in many places it's in perilous condition. We're actually overusing our groundwater resources. That means we're mining them just like we would be taking oil out of the ground. And you know very well, Chris, that everything, as you mentioned, is sort of on an exponential function of some sort, and water is one of those things too that seems to be on this exponential function, and in a finite world that just can't continue.
So we have two types of water. We've got surface water, lakes, ponds, streams, and then there's the groundwater, the aquifers. So you're mentioning that west of the Mississippi there are aquifers that we're drawing down at faster than the recharge rates.
Correct. You know, you can't overuse surface water because it just won't be there. The river dries up. You can overuse it in terms of not leaving enough water for the environmental needs or environmental services provided by surface waters. But when you run out, you run out. But groundwater is a different thing because you can tap groundwater that was stored in previous periods of time, years or maybe centuries earlier. And this then becomes like mining of any resource. And we do have the problem that we have some of our major aquifers, the Ogallala aquifer, for instance, which is the aquifer that underlies the whole Midwest, and it provides maybe 30% of the irrigated waters. I don't know how much, but way up there in the percentage, and it's being severely overdrafted. And then the San Joaquin Valley, that's the valley south of the Central Valley that's south of the Sacramento Valley, is being overdrafted seriously also. So we have two major agricultural regions with overdrafted groundwater.
And if they don't have water to pull from those aquifers at some point, or somehow society says we'd rather not use this for agriculture, we really need this for, civilian populations. If that day comes, what are their options? Well,
the options are to quit taking it then. And, of course, then your question is what are the options for replacing the food that was being grown with it? And there, fortunately, are some options. But let me mention a little bit, it's not as simple as that, about the fact that as you overdraft a groundwater resource, what happens is it gets further and further down to where it is in the ground, right, as you'd expect. In other words, the level that you're pumping from increases. And so it gets more and more expensive to extract any amount of water as you deplete the groundwater resource. So you've got the depletion going on, plus you've got an increase in energy costs to get the water out of the ground.
I've heard water's heavy. I have it on good authority that water is a heavy substance.
You are on very good authority on that issue.
Right.
And you know, it's a huge thing. I mean, it takes maybe thousands of times more water and weight than any agricultural production you get from it. So you've got a lot of water to lift to get a bushel of wheat or corn. maybe 1,000 times as much as the weight of the bushel.
So 1,000 tons of water for 1,000 tons of wheat?
That's right.
All right, well, let's talk about the global picture then. We've mentioned the Ogallala and the San Joaquin, the couple aquifers here in the U.S. that maybe are being overdrafted, as you say. So what's going on across the world as you look out there?
Well, the same problem is going on in India in a big way, in China in a big way probably, throughout the Middle East, North Africa particularly, in a big way, to some extent in Canada. And, when you get all that together, it's a very, very large amount of our total food production is depending on a diminishing supply of water. So it is not a trivial problem. It is a very serious problem to address. And the question is water so scattered in such a low intensity in terms of financial intensity resource that it's very difficult to have a very strong management system, because if it's lateral spread.
Well, is this an issue of maybe just needing to just move the water around to where it's needed? We have, I guess, the Great Lakes are full of quite a lot of water. The Southwest seems to be a little bit light on water. Tell us how water is managed and whether or not it's a realistic idea to just say we'll take it from where it is and move it to where it's needed.
Well, there certainly are there are plans in various parts of the world to do it. And for instance, we have a plan here that's been in place or been talked about since maybe the 1960s of moving water from Canada down into the southwest of the U.S. It's a huge, it's a very, very expensive, big proposition. When we think of moving oil around, that's a big proposition, but the amount of water you'd be moving is many times greater than the amount of oil you're moving around. Because its economic density, you might say, is much, much, much lower in today's world. In other words, the value of a barrel of water and the value of a barrel of oil are very, very different. So you've got a very low-cost item that's heavy, that's hard to move. You do have more water in some places, like as you mentioned in your part of the country, you've got more water than you need, and you theoretically could move that water to Kansas, or you can move water from Canada to Kansas or to Nebraska. That's where the Ogallala aquifer is. And you could take care of that, but it's a very, very large expense. And then you've got the expense of all the energy it takes to do it. So you sort of get into this natural resource bind or physical resource bind that we're kind of encroaching on with the exponential increase in energy use and water use, and then besides that, you need a lot of metals to put pipes together, or perhaps a lot of materials of one sort or another. So it becomes a very difficult issue and becomes more expensive. It was expensive 60 years ago. It's more expensive today, and it'll be more expensive tomorrow in terms of as the resources get more and more strategically used up.
There was just a big article in Wall Street Journal, I believe yesterday, and they were talking about mining companies, and of course they were talking about them from the commodity side of the angle, saying, wow, if China ends up having a decline or a collapse of some sort here, commodities are really going to take a hit. But buried in that story, they were talking about the idea that the mining companies had been experiencing inflation for running their operations in both energy and in the machinery. So I look at the machinery as sort of it's a proxy for energy because it's made out of a lot of steel. So they were experiencing inflation of over 11% per year for about the last decade. And so that's what they're experiencing there. So I'm translating now and thinking that if you wanted to build something that could move water at a scale necessary to deliver useful amounts for agriculture, which, irrigation, I'm imagining we're talking enormous quantities of water. So these would be either extremely enormous pipes of some sort or very, very large culverts that might as well be rivers. And, of course, we're moving this across geography, sometimes against gravity, so there's pumps involved and there's energy involved in that. Tell us, I mean, fill us in as best you can. What's the reality of moving a big amount of water from one place to another?
Well, you've just laid it out very nicely. The reality is that it takes huge works to do it. One of the irrigation projects that I've become very familiar with because I've worked there a lot as a consultant, and that is the Imperial Irrigation District of Southern California, which happens to be the largest irrigation, contiguous irrigation piece of land and district in the U.S., and it has, in acreage terms, they have around 500,000 acres of land. And they bring their water in from the Colorado River through what's called the All-American Canal, which is all-American because it's all on the American side of the border between Mexico and the U.S. And their largest canal is, you'd consider it a very good-sized river back in your country. I'm back in the East. Mm-hmm. And it takes 7 days to get the release of the water from the Boulder Dam up near Las Vegas down the river and then to the irrigation district, and another day to get the water from the inlet of the irrigation district to the last part of the irrigation district. So you get a feeling for the size of the scope of this thing. And the canal that is an open canal that is the biggest of the three major canals on the project or the district is about it's what we call 3,000 cubic feet per second of water flow. Now, many Americans wouldn't think, what is a cubic foot per second? Well, that's 450 gallons a minute is a cubic foot per second. So I haven't done the math, but quickly 3,000 times 450, you can see it's a very large flow of water when you think about it.
Yeah.
And
is that all gravity fed, or do they have to pump that?
That's all gravity fed, but to put that in a pipe and run it uphill and downhill and all those kind of things is a huge undertaking. And that's just one piece of an irrigation district. So to move huge amounts of water in open, first of all, you'd probably try to do it in open canals, and then you have to go into pipes to get it uphill anywhere, of course, or pipes to get it underneath something. In other words, we have kind of inverted siphons, we call them. That's really not a very good word for it, but it's kind of a U-tube that goes underneath something and comes back up on the other side because water seeks its elevation again. Mm-hmm. But anyhow, the works are just gigantic, and you've got exactly what you said about the mining issue, and that is, you think things are expensive now, and you say, well, we'll be able to do it in the future when water becomes a little more expensive, but then everything else is more expensive to do it with. So it's kind of something you never can get your arms around again.
It sounds like the shale oil plays. It's a very similar
well,
thing.
Well, it's the same thing as the mining type issue you mentioned in China, for instance, and that is that the cost of all of the things you need to mine is going up pretty fast.
Yep.
Because all these things are also probably things that are being mined somewhere else, if you think about it.
Yep. It all hinges off of energy at some point. So. Well, let's think then, the UN has said by 2050, they've sort of projected that maybe the world kind of needs to double its food output to account for the fact that we're looking at a 25 to 50% increase in population, and living standards seem to be going up. So a huge portion of our green revolution, a lot of people think that was high technology. It was fancy plant breeding and maybe some genetically modified this or that or something really more clever. But a huge portion of those gains over the past 50 years were from irrigation. So,
well, you're exactly on there. What happened is they were from genetic, but normal genetic manipulation through plant breeding. That wasn't in those days. Borlaug and the people that worked in the same area, they really did it just with plant breeding. In other words, that just meant taking superior plants and crossing with superior plants. and no genetic modification in terms of manipulation of genes and stuff like that, in terms of directly manipulating them.
Mm-hmm.
And they produced plants that were highly productive, providing they were well fertilized and well watered.
Mm-hmm.
So what they did is the indigenous food plants all over were more, adapted to kind of low fertility, low water, whatever happened kind of situations. And by getting plants that would, and if you gave those indigenous plants a lot of water and a lot of fertilizer, they really didn't do that much better. But these new plants did a whole lot better. And so that really solved the problem, because you could have plants, crops that produced way more with getting good water and good fertilizer. But the whole thing was a triad of inputs, and that was the different seed, more fertility, and more water.
Well, so as you look across the world, how much of a role, let me put it this way, how much can we really expand irrigation at this point? Are there big aquifers that have not yet been tapped, or are there bodies of water that have not yet been run? I mean, this is kind of globally. I know that there are big issues with a whole portion of China. Their main aquifer that they've been using has been drawn down so severely they're down 1,000 feet chasing this stuff, sometimes in some cases 1,000 meters. I mean, it's incredible how far they've gone and drawn these pieces down. I'm just wondering, as you survey the water assets that exist and remain in the world, how much of an opportunity are we going to have to sort of repeat that green revolution, at least with respect to irrigation as we go forward?
Unfortunately, we're sort of near the end of our string. We do have opportunity with some better methods of irrigation, some methods, and I think the thing we call drip or trickle, that's the irrigation where there's a little pipeline running down every row with water oozing out or dripping out of outlets that are close to each plant. With this kind of close irrigation and high-performing irrigation, I'd say, we do get a bit more productivity out of the same amount of water.
Mm-hmm.
And actually, the thing that is really perplexing to most people, and they don't seem to get it, and our politicians don't seem to get it too well, because they like to hear there's a magic bullet to everything, that is that when we apply water in agriculture, the only water that is missing after we do it is the water that evaporated from the ground or was transpired, and that transpiration is the word we use for the water that passes from the root zone up through the leaves of the crop. That's the water that is missing. The water that's put on excess in irrigation that is not consumed by either evaporation or transpiration of the plants themselves really is still in the system somewhere. In other words, it goes back in the ground and it seeks its way back and often runs out and it becomes somebody else's water supply. So people think that if we make irrigation more efficient, in other words, more of it gets evaporated and transpired, then we'll have a lot of extra water left over. And the problem is that's not the case, because the water that wasn't consumed by evapotranspiration, and we combined the evaporation word and the transpiration word to evapotranspiration, a single word, that water that wasn't consumed by evapotranspiration is still in the system somewhere. It may be degraded in terms of having picked up some pollutants, the main pollutant being mineral salts, that it's not as good in terms of producing crops again, or maybe it isn't even drinkable, but it's still there somewhere. So improving irrigation efficiency does not get the gains that many people think might be out there. So we're really lost. We're lost for how to really make our water go further, except just to manage it very carefully. But we only get relatively small gains out of that.
So let me ask you this question, because you mentioned the mineral salts, and I'm intrigued by that idea, because a lot of The groundwater, I know, comes in various flavors of salty, mildly salty to very salty. There's stuff that's almost brine that comes out when they're chasing certain oil finds. So as we look at that, is really, if we think about sustainable agriculture, maybe this is off your reservation a little bit, but I want to focus on the water part. So here we are, we've got this giant aquifer, we're pumping water out, we're irrigating with it. Is that 1,000-year sustainable plan, or, is the in Mesopotamia, they had that golden triangle where they were growing all kinds of stuff and ended up salting their fields, I believe largely through a process of irrigating with very salty water. How big of a problem is that, and is irrigation really just sort of something that works for a few decades, or is it something that really could be managed and would work well forever?
Well, it can be managed and work well forever, fortunately.
Good.
What that requires is just like if you're washing your clothes, you can't keep washing the clothes in the same dirty water. So if you continuously flush the dirty water out, you can keep the washing machine washing clothes cleanly again. And the same thing would be true in water. I kind of maybe not the best of examples, but this is sort of what you have. So we can provide a way to get rid of the salty water or the salted water. And theoretically, if you had enough energy, you could take the salt back out of that water and use it again, even if it got quite salty. But that then becomes an energy sink. But we can keep this an agricultural system. We have the other side of agriculture. Irrigation is drainage. So we often call it irrigation and drainage. In fact, we talk about the water industry in terms of agriculture as being irrigation and drainage, and we sort of put those in the same sentence often because we realize that we need to pay attention to the drainage and keeping the salts out of there. The other thing in Mesopotamia happened is that not only do you have the salts in the water, but you have the groundwater getting, if you keep putting surface water on, which they were doing in those days because they didn't have a means for doing a lot of groundwater pumping, they kept putting water on, and the water table, you might say, came to the surface itself. So not only did they have salinity, probably, but they also had what we call water logging. In other words, the plants can't grow when the water is at the table is at the surface because the roots don't get any air. Mm-hmm.
So as we look across the world, you say that we've sort of hit some limits. There may be no big, giant, unexploited bodies of water for us to really go after. In some regions of the world, obviously this is a really serious deal, Mideast being an obvious area. Any arid area already is dealing with these issues. So in your mind, what should we be doing either at the national or the global level right now that we're not doing when it comes to water?
Well, I think at the national level where we have a strong legal system, we do have regulations that curtail the use or have the capability of curtailing the use of groundwater. So we do have a legal system and a property rights system called water rights that can be used to curtail the overuse of our groundwater resources. And little by little, this is being implemented in everywhere that the water is overdrafted. But, for instance, in the Central Valley of California, they still do not have a water law that restricts the extraction of the groundwater from underneath the San Joaquin Valley. They do in California, and incidentally, let me back off a second. Water in the U.S. is a state's rights issue. In other words, the law of how to use water is an issue that each state has the right to do their own way. So every one of our states, our 50 states, has a different water law. And they're more or less the same in the West and the East, but they're not exactly the same in the West and the East. And the water laws include what to do with surface water and with groundwater. So they do, most all the water laws of every state will have some difference between the two systems of supply. And, of course, all water to begin with was part of the commons. In other words, it was in nature somewhere, and people then tapped it and used it. And in the West, the concept was the first person in line to use it had the prior authority to continue using what they had developed. It was protecting its first in time, first in right sort of concept. And that's a typical Western water law. In the East, they had riparian rights for water in general sense, in your part of the country particularly, that said, that we could use water, but we could not deplete water. So they really didn't allow much depletion of water. Which you had the right, if you're near a stream there, to use the water for your benefit. And I assume deplete it, but in a way you really don't deplete that much unless you start irrigating, because most of what you do ends up going back into the system again somewhere, your sewage system. In other words, people downstream literally do drink the sewage from the people upstream. Mm-hmm. And that's just a fact of life in a sense. So we have these water laws, and the two are sort of separate. The surface water law is definitely there in most every place in the West, and it's pretty closely tied to the first in time, first in use, first in right. The question then is that what is considered beneficial use, because we tack another word on it for the use being beneficial. You just can't take it. You have to use it beneficially. So that makes a whole legal system of water in every place, and the U.S. government enters the picture when it's an interstate dispute. Within a state, it's all in the state, but between states, it becomes an interstate issue, and then it becomes a federal issue of what to do about people that are arguing over the right to water.
Well, beneficial, I was in Phoenix recently, and it was well over 100 degrees every day I was there, and this was pretty late fall. And I see that their definition of beneficial includes a lot of golf courses. I assume that's Colorado River water or something coming down and putting that there. As you look at a place like Phoenix and you see how they're using their water, what sort of issues come up in your mind over the long term?
Well, if you forget about climate change, mm-hmm. I think you have to, in the long-term thinking, you really have to say, climate seems to be changing. I don't. There's all this argument about it, but what's hard to dispute is it seems to be different, creeping along a path of different conditions as time goes on. And all of our water systems that we have put in place and developed are based on, the rear view mirror. In other words, we expect the future to be like it was in the past. And so if you got a place like Phoenix, and if the past, if we don't have any change in the way the Colorado River functions, and which is part of their big piece of their water supply, they can continue the way they are. They can't continue a growth concept that they're going to keep getting bigger and bigger and bigger, and more people moving there and doing the same thing they've always done. In other words, having more golf courses and more of everything else, because as you point out so well in your discussions and seminars, that's an exponential growth, and it reaches its limits, and they are at their limit already. And now if we have climate change on top of that, in other words, if there are some long droughts coming, they're going to not only not grow, they're going to have to back off. And backing off creates a huge amount of disruption economically and politically, economically and, of course, politically and socially. Mm-hmm. And so the long-range future for a place like Phoenix, assuming that we don't have a drought, will be sort of leveling off and sort of bumping along where they are. But things will just keep getting more expensive in terms of moving the water around. And if there's climate change, they're going to be in a world of hurt in terms of having to back off and shut down some of the golf courses and quit irrigating lawns and stuff like that.
Yeah, sure. The climate does shift, and where I'm sitting in Massachusetts, 10,000 years ago, there was about a mile of ice here. So I'm reasonably certain that things change over time. I note that this was, I believe, the hottest, driest set of summer for Arizona, Texas, New Mexico, and they had wildfires and they had all kinds of water issues. But to their great benefit, I believe the snowpack was just incredible up in the to the north of them, up in the Rockies, where a lot of their water originates as it comes down the surface waterways. So they got a little lucky on that one there. And as I look at that whole scene, I just see that the growth path that Phoenix is on, I say it's unsustainable. Obviously, you can't keep exponentially growing anything forever, but the particular model that they've pursued, which is very water intensive in that particular region, seems to me like a place I wouldn't want to put legacy family heirloom money into something like real estate, because I'm not quite clear on what happens there as that part of the world goes forward. It's not clear to me from the outside, but I don't spend a lot of time on it. And if you do, do they have a plan? Does somebody have a plan? Do you see a set of plans that particularly speak to maybe the drier areas of the Southwest that you could point to and say, that could work?
I'm afraid I don't think there's a plan, and there's so much political. There's so much resistance to having a plan that the politics are practically impossible. So we probably have to go into crisis, and then after crisis, you develop a plan to deal with the crisis. But in terms of pre-planning before the crisis, the absolute crisis, I don't think people will have the capacity to do that in the way the political system works.
Well,
in the money system. If
it doesn't exist in the political system, I do trust then that there are entrepreneurs or businesses or companies or individuals who are out looking around who see the opportunities here. And I know that people say that investing in water is a great idea, and maybe it makes sense in some portfolios. But what does that mean to invest in water, and how is that being done today? Investing in water
is kind of a messy and difficult thing in my view. Maybe I'm personally tried to figure out how to invest in water, and I'm really not quite sure how to do it. The only way that I know to directly own water, because water is a property, is to, and usually it's tied to land, it's to own irrigated land that has water rights. The water that is not on irrigated lands, a golf course, in effect, could be an irrigated, if you could think of that as an irrigated land. And if you have the water right to irrigate your golf course, then you have a water right. And a city has water rights, but that's usually already in the public domain if it's a city water right. So the one way to own directly water, like owning an oil patch or something like that, is to own a piece of agricultural land with a water right on it. Mm-hmm. The next thing you can own, and just like you could kind of think of it as mining. I mean, you could own the mineral resource. So you could own a farm in Kansas that really, they do have groundwater rights there now established, and you own the right to take water out of the ground, like mining. The next thing you could own is you could own things that move the water, like pumps and pipes and things like that, so you could invest in water infrastructure, hardware. That would be a place to invest in water, that includes both from the domestic side, all the stuff that goes to making municipal, city, urban water systems, and from the farm side, the people that make irrigation equipment, as being in the farm side of owning the infrastructure, the people that make the infrastructure, the hardware for using and moving water. So those are the kind of the two places you'd be, and maybe you could be in a third place that would be something I don't know, maybe you could own a bottling company that had some spring water rights that they had, and you could own water that way instead of farmland. Don't really know that business well enough to even comment on it, except to say it must be a possibility.
Well, certainly it sounds like efficiency is clearly one of the easiest, lowest hanging pieces of fruit. And so you mentioned one at the beginning, drip irrigation seems to be more efficient. But, we all saw our toilets changed in the past 2 decades from higher flow to lower flow, a more efficient model. So perhaps efficiency is and this is the same, I look at water and it's the same message and story I hear around energy, which is that it's not very sexy, but the easiest thing to do, as always, is to save some rather than figure out how to get more.
But let me caution everybody on this efficiency issue, and that is that a low-flush toilet that's in a toilet that's upstream somewhere in the system, in the basin, does not make any more water for the basin.
Mm-hmm.
It reduces the amount of water the city that has the toilet has to clean up, because we literally use our drinking water. In our cities, we have the same kind of water in our toilets as we have that we drink. So it reduces that pressure on the city to acquire and clean up water. But the discharge from the sewage treatment plant of that city is part of the supply downstream. So unless that city's on the coast, there was really not a big water savings by being more efficient with the toilet. And the same thing is true in agriculture. So the efficiency becomes, did you really get more done with the amount of water you consumed, as opposed to did you just deliver, and did you reduce your delivery, but you used to take most of your delivery and turn it back to the system again after you used it and cleaned it up.
Right. I looked at the statistics briefly. It turns out residential use of water is actually very low down on the list. It's fairly nominal compared to agriculture, obviously being a big one. But this was a surprising one to me, was power generation. Power plants seem to be extraordinarily huge consumers of water.
Oh, the thermal-type power plants evaporate a lot of water in their cooling system. That's where they consume water.
Yeah, billions and billions of gallons. I mean, it's a lot. It's very, very big.
It's a lot. It's a big chunk of water. It's a big piece of water, and that is the consumption of water, the boiling off the water. And power plants could probably do with less water, but doing more straight air cooling. That would mean bigger, more expensive coolers to get by without so much water. So there's some things you could do there that would actually reduce the evaporation of water. So I was mentioning earlier on, it's the evaporation or the evapotranspiration of water in terms of agriculture. That's the real reduction of water, and also the reduction in the pollution of water. And our Clean Water Act went a long way to make a big difference in water used in industry in general, because by making industry clean up the water, they just decided not to use so much.
Mm-hmm. Right.
So that was a big boost in water. And when I talk about some of the forms of irrigation, the drip irrigation, or the very highly controlled irrigation, actually gets more productivity out of the water that's evaporated and transpired. So it gets a bit more productivity, not huge amounts, but some more. It's in the neighborhood of 20 to 25%, which is significant.
Right.
In other words, if you drip irrigated tomato crop, you'd get more tomatoes for the same amount of water that you'd get than you would have consumed by evapotranspiration from the crops, as you would have gotten with surface irrigation.
Right.
So that's really a big gain, and there's a fair amount of that. But remember, that's a very expensive thing in terms of material, and it takes pumping pressure and all these things, and so you got a lot of energy going into making water more efficient. And as you point out so elegantly in your own discussions, that's a problem.
Or maybe it's a predicament somewhere. So
it is a predicament. It is a predicament.
So let's. So as you look forward, these water issues, are these things that are going to be, are these 20 years away? Then you think there's an eventual crisis that happens, or are these things that are 10 years away? Are they 100 years away? Where on our concern list, do you put water as something that we are going to have to deal with in maybe a fundamentally new way because circumstances say we have to?
Well, the thing is, let me wind back a second. The water is so variable and so site-specific throughout the world nothing is going to happen all at once anywhere, and it's going to be a creeping thing. And what will happen is there'll be more and more pressure put on the shortage of food, for instance, because it'll show up as food shortages, or it'll show up as, well, that's probably where it's going to show up the most, because agriculture is by far the biggest consumer of water. When I say the consumer, it's the one that has the most evapotranspiration.
Yep.
And so what it'll be is, the stresses will be localized, and the solutions will all be localized. In everywhere there is a solution, and everywhere you reach some kind of a breaking point. Some places will be capable politically, be stable enough politically, and have strong enough systems to cope with it, and other places will just suffer the consequences of waiting till the crisis is beyond solution almost. In other words, people dying or whatever happens.
Well, here's how it's not a local issue for me is in food, as you mentioned, because we saw, so maybe what was it, a year ago, the Ukraine had this extraordinarily bad drought, and it led to fires that ended up burning up a bunch of krauts. And then down in the Queensland, Australia area, they had the opposite problem. They had this huge flooding, which again wiped out a pretty significant chunk of wheat crop. And the next thing you knew, the globe was facing higher wheat prices. So the extent to which we're going to see crop impingements or even failures because of aquifer failures, it does become a global issue in terms of food prices, although the crisis itself will be highly localized. I have pretty big concerns just, scratching on the napkin, taking a look at what we're kind of expecting and anticipating in terms of food productivity growth over the next 10 or 20 years and where that's really going to come from, and noting that water seems to be a potential limiting factor in a whole bunch of regions that are currently quite productive in food production.
That's right. What we're going to do is we're going to be trying to make gains, and let's go to one other thing that would be dear to your heart, and that is that nitrogen fertilizer, which comes from fossil fuels for the most part, is another piece that's going to be more and more limiting. So, and phosphates. So fertilizer and water are going to be limiting, and there's all kinds of work going on trying to get around this with genetic modification, or whatever you want to call it, GM foods, and there are all the dangers associated with genetically modifying our food system. So we're reaching this limit to growth that people are in denial about. And the question is what is the carrying capacity of the world? We can certainly back off in our eating habits and ways and convert more things into agriculture. In other words, golf courses don't need to be golf courses. They could be growing food. And I think people would be more interested in food than playing golf at some point, maybe. So there's a lot of elasticity in the system to move into food and to change our food habits and things like that, and some room for improving the amount of food we grow with the water. And it'll be all these things that will be the way it's tackled, frankly. It's not going to be tackled on the water itself, because we may be smart enough to do what we can in local areas, and other places, as I mentioned, they won't do it that way. They'll just use it up.
So if the past was all about just tapping more of the water that was there, the future is about using what we already know we have and figuring out how to be more clever about it. And so it's just, let's put it into the sweep of what we see coming. It's just another thing that's going to require good, hard, conscious thought, trade-offs, prioritization. In short, doing things kind of differently than maybe we've grown accustomed to doing them.
That's exactly right. And the world, with the 7 billion people here now, it can feed itself at this point. I'm not sure that everybody can have chicken every day or beef every day and that kind of thing, but there's certainly enough food could be grown. And we could probably back off on our overdraft of our aquifers and maybe even figure out ways to retrieve them a bit, in other words, resupply them. But it would take a very much more managed, technically managed world than we have, and one that was just not hell-bent on consumption, but was looking at, you might say, conservation and rejuvenation of things. But it's a very different society than we see ourselves in at this moment, I think.
Well, thank you for that, because that is the larger narrative that I think occupies many different facets of our existence, and it's this shift from consumption to stewardship. It means going from not really having to think very carefully to needing to think much more carefully, understand the system itself. It's not just, as you mentioned, it's not just the water you dump on. We have to know where the water goes, and we can track it, and it's irrigation plus the drainage and, knowing where the evapotranspiration. There are complexities involved, of course. And so I think that's where we're going to leave it for today, is this idea that water is part of a complex system. It needs to be managed if we want to use it well and efficiently, and that there are let's say, opportunities for improvement in how we currently use our water and manage our water. And your summary is that it needs to be much more actively managed if we're going to avoid some painful adjustments in the future.
Well, I think that's a very good statement to sort of end up with. And let me put in one comment, is that we really just can't continuously ignore the environmental services that water in streams play for us. And so part of the rejuvenation of the system is to take care that, and to be careful that we don't over extract and over commercialize or commoditize all of our water in certain places. The other point to bring up in that is that the water is a local issue, because water is basically local. Even if you transport it quite a long distance, it's still pretty local. Relatively local, and each area, there's not a solution for all areas. There's a solution for each area that fits its area, and that then involves, in each country, its political system, its economic system, its legal system. In India, there's no legal system that really stops anybody from tapping groundwater anywhere. So they've got a long way to go to really bring certain kinds of thing under control. Probably in China, they would have control on that kind of issue, because it's a top-down society. So each place will have its own way it has to handle it. And there's not a master plan for the world.
Very well said. Well, I'm Chris Martinson of chrismartinson.com. Of course, we've been speaking with Jack Keller, CEO of Keller Blissner Engineering, about water and water issues. Thank you for listening, and have a great day.
This concludes this podcast by Chris Martinson. To gain further insight into where things stand today and what might happen tomorrow, please visit chrismartinson.com. That's CHRISMARTENSON.com. Please join Chris Martinson next time to continue your journey toward awareness, understanding, and action.